Previously on What is Probability? So last time we talked about a deck of cards and pulling one card out of the deck. We then discussed what is the probability that that one question mark card is a diamond and an 8. A diamond and an 8 is only 1 out of 52 cards. Then we discussed OR, and how and OR are not at all the same. The probability that it is a diamond or an 8 is actually quite larger. It's 16 out of 52. In this second case, we don't care whether it's an 8, we don't care whether it's a diamond. It could be any of those diamond cards, any of those 8 cards. The AND is also known as intersection. That's because that is where the 8s and the diamonds intersect. It's where they cross over. OR is also known as union because we combine everything all together. After that, we took a look at what happens if we already have information. Like, what is the probability is an 8 given we know it's already a diamond? So we've got all of these diamonds. What is the probability we pull an 8? 1 out of 13. Notice, in this case, none of the other cards matter. We don't care about the hearts or the clubs or the spades. All of those are absolutely useless to us because we are given it as a diamond. So our only field of vision is diamonds. If we switch up the condition, the probability also has to change. In this case, we are given it as an 8. So we are down to just the 4 cards that are 8s. One of them is a diamond. These conditions make our probabilities completely different. What is probability? Episode 2, Multiple Draws. Illustrated and narrated by Isabel. Alright, so when we left off, we decided to pull 2 cards from the deck. This is a very complicated problem, so we're going to start with dice games. When we have a die, we've got a population. We roll that die, and that population are the 6 sides of the die. That is all that the die has, just those 6 sides. That's called our sample space. When we randomly roll the die, we randomly choose a sample from that population. And that sample could be a 1, it could be a 5, it could be any of those 6. That's why we call it a sample space. So let's talk about dice games, because most of the time, like in Monopoly, we're not rolling 1 die, we're rolling 2. So let's talk about rolling 2 die before we talk about pulling 2 cards. When I roll the first die, it gives me 6 options. That's my sample space for the first die. When I roll the second die, that gives me another 6 options. However, my full options are not going to be just those 12. It's going to be the product of that. We have 36 different possibilities. I could roll a 1 and a 1 and get a 2. I could roll a 1 and a 3 and get a 4. Filling out the chart, we get this many different possibilities. This is our sample space for rolling 2 dice. Notice, it's far more complicated than just rolling 1. So say I'm over here on chance, and I want to get to go. That would be exactly 4 spaces. Exactly 4 spaces can be done by rolling a 3 and a 1 or a 2 and a 2. So there are 3 options in my chart. That means 3 out of 36. Probability, about 8.3%. So pretty unlikely that I'm actually going to land on go. Where would I land? I'm on chance. What's the most likely space for me to land? Well, if you notice on our sample space, the most likely is 7 spaces away. That is the most likely sample that we have because there are so many more 7s than other numbers. 7 spaces would be all the way here at Baltic Avenue. So 6 out of my 36 in my sample space means it's about a 17% that I'm on Baltic Avenue. Still unlikely, but double the probability that I land on Go. In fact, it's more than the probability. More than double the probability that I land on Go. So when you're on chance or any other space on the board, where you're going to end up is approximately 6, 7, or 8 spaces away. That is what is most likely going to happen. Could you land 5 spaces away? Yes, but it's not as likely. So from chance, you'd reach about income tax or community chest. That's 16 out of 36, so 44%. Almost about half the time, you will land in that general area. As I say, it's definitely possible that you land on Go, but unlikely. You're more likely to end around that area. Say you're on chance and you want to get to Park Place. Notice that's 0 out of 36. Although 1 is a possibility for when you're rolling just a single die, 1 is not a possibility when you're rolling 2. Go figure. The lowest our sample space goes is 2. So you cannot get to Park Place from chance unless you go all the way around the board. Similarly, if you want to get all the way over here, not possible. You can only go 12 spaces. That's the farthest you can go on the board game. So getting all the way to Connecticut Avenue, 0%. In fact, getting anywhere to Connecticut Avenue or beyond is 0%, because the dice, the largest you can get is 6 plus 6, which is 12. So now let's go back to our cards. For the first card and the second card. Well, for that first card, we have 52 options. And for the second card, we have, yes, 52 options. That is a whole lot of possibilities for our sample space. Writing out that many possibilities for our sample space, not interested in doing that. No, thank you. That would be a no. Most of the time when we're working with cards, we just tend to work with the sample space for drawing one card. And we have to do some math to figure out what would happen if we wanted to get a second card. So what is the probability that we draw 2 diamonds? Well, that very much depends. Are you drawing a card and then putting it back in the deck? That means with replacement. So I want to find a diamond. I draw a card, that's a question mark. I then put it back in the deck and shuffle it up. I pull another card. What's the probability that both times I pulled a card, I got diamonds? Well, because I replace and shuffle each time, I should have the same chance each time. So I could get the 2 of diamonds both times. I could get the 6 of diamonds and the 8 of diamonds. So it's going to be 13 diamonds out of the 52 cards times 13 diamonds out of the 52 cards. If we go back to that big chart, I'm basically finding the area, multiplying the base times the height of all of my diamonds. That gets me a 6.25%. So pretty unlikely, but possible. Most card games do not happen that way. What is the probability we draw 2 diamonds? Definitely regularly means without replacement. So that means I'm looking for diamonds, I draw 1 card, and then I draw a second card. Well, for my first card, I've got the 13 out of 52 probability again. But for my second card, I don't have the 13 out of 52. If my first card is a diamond, that means I've already chosen one of the 13 diamonds, leaving only 12 remaining diamonds. I've also chosen one of the cards, obviously. So my 52 cards goes down to 51 cards. This actually makes a lower probability. So let's take a look at what would happen if we're playing Crazy Eights again. Crazy Eights or Uno, one of my favorite games. So we've got this deck, and we're saying you can't play. What's the probability you draw 3 cards and still do not get to play? Well, the probability will change with every single card that is drawn and every single card that you play or that any of your friends play. So, this is obviously without replacement. We start with the Queen of Hearts. That is turned over first. So the Queen of Hearts is now off the docket. No one can play the Queen of Hearts because it's already been played. Then the 9 of Hearts gets played by someone else. Then the 9 of Clubs. Then the 9 of Diamonds. Finally, the Queen of Diamonds gets played, and it's your turn. So it's your turn to play, and you can't play because clearly you have no diamonds and you have no queens. You need to pull a card, or maybe 3 cards, or maybe 10 cards. Who knows how many cards you're going to need to pull? So let's take a look at the probability. Your mission is to get a diamond to play on the Queen of Diamonds, or to get a queen to play on the Queen of Diamonds. You can also get an 8 because we're playing Crazy Eights, which means 8s are wild cards, and you can change whatever the suit is to whatever you want it to be. So what's highlighted in gold are what we want one of those 3 question mark cards to be. Notice you can also cross out a whole bunch of other cards. I crossed out the 6 of Hearts, the 3 of Clubs, the Ace of Spades, the 7 of Spades, and the King of Hearts. That's because that's already in our hand. We can't pull the 3 of Clubs from the deck because it's already in our hand. So it can't be one of the question mark cards. These are all conditions that help inform what those question mark cards are going to be. And the most basic form of card counting. Card counting gets more difficult, and there are different ways of card counting, but the easiest way is just memory. If you remember what cards have been played and what cards are in your hand, you can calculate the probabilities fairly quickly and simply. The probability that the first card you turn up is going to be useless to you is about a 62%. If we take a look and we count all of those white cards that are not crossed out, that's 26 cards. Now, the 42 comes from all of the cards on the deck that are not crossed out. We've crossed out a whole bunch of cards either because they've been played or because we have them in our hand. So we're no longer working with the 52 cards in the deck, we're only working with 42 cards. And the white cards are 26. Now, what's the probability that the first and the second question mark card do not help you? Well, say we pull the 4 of Clubs for our first one. That's the 26 out of 42 possibility. about a 26 out of 42 possibility that I pull one of those white cards. So I'm saying, for instance, the 4 of clubs. It could be the 10 of spades. It could be the ace of hearts. But let's say you pull the 4 of clubs. That means that we've crossed out another white card. So you only have 25 possible white cards and 41 possible cards in your next draw. This continues for the 3rd card. And for the 3rd card, you would only have 24 possible white cards left out of 40 cards left in the deck. A 2.3% possibility. So, it's only a 2% probability that you pull a useless card 3 times. In this case, it's actually fairly good probability that you'll get one of those golden cards in the 3 draws. In the 3 draws, that would be the opposite, or the complement. So in 3 draws, you would have a 97% chance of getting one of those golden cards that will allow you to play. So pulling cards, not too much of a problem. As the game wears on, it becomes more and more difficult, and the probability that you will get something that is more useless continues to grow, because cards keep disappearing and you keep crossing them out in the deck. This becomes very complicated. So, in order to make probabilities less complicated, two-way tables were invented. In these two-way tables, we fill in exactly what we want. We want diamonds, we want queens, and we want crazy eights. We then have to talk about what happens if we don't get a diamond, or we get one of the other ranks that are useless to us, but possibly helpful if it's a diamond. These two-way tables will then assist us in actually calculating out the probabilities. However, the simplifications of probabilities, they deserve an episode all on their own. Tune in next time as we talk about how to simplify calculating out different probabilities.